Hi all, welcome to part 13 module 2 computer networks. So we were discussing that go back and protocol in the last lecture. And now before moving on to select to repeat, I think we have to be clarified about the sequence number concept. So that's something which I kept means without much discussion, but in the sliding window protocol I given you a hint about the sequence number. It has to be at least as the center window size, because how many are being at a transit at any time, that is decided by the center window. If 4 are there in transit at any time, then 4 minimum sequence number should be there. But if is that 4 enough, that is the question. So the relationship between the window size and the sequence number, the sequence numbers required should be at least equal to the size of the window in any sliding window protocol window, particularly center window. So the minimum sequence number required particularly in go back n, it is n plus 1. See what is n? The center window size. See, let me take the pen. So what is this n? The center window size. And what is this 1? The receiver window size. So you have to consider these two, and the go back and the sequence number minimum is found to be, so this is the final result and we will see why it is. So we already know that it should be at least n, but if I am making it as n, there is some problem, something I already told you, and that problem we will see and how we can solve it just by increasing it by 1, and this 1 is actually the receiver window size. So in general you can make it as a formulation like the minimum sequence number is center window size plus receiver window size, or the sequence number, the number of different sequence numbers needed should be greater than or equal to center window size plus receiver window size. It should be as minimum as this sum. So that is a general formulation, but before moving on to that, you should know why it is so, okay? And that is what we are going to explain now. Let me clear the things. Yeah, bits. So if it is n plus 1 is the number of distinct sequence number we need, then we'll take logarithm of it and take CL of it, and that will give you the number of bits required to represent this sequence number field. So this extra 1 is required in order to avoid the problem of duplicate packets as described in the next slide. So we are going to describe that situation. So we will take an example of go back 4 and we will try to explain the scenario. The center, so in the go back 4 protocol, the center window size is 4, and therefore we require a minimum of 4 sequence number for sure to label each packet in the window distinctly. So assume that the sequence number minimum we taken to be 4, and what is the problem with that? If everything is going fine, it will work. Now suppose that the receiver has received. So now we are going to say see a special case where it is not going to work. There is some kind of counter example. Now assume that suppose the sender has received packet 0, 1, 2, 3. So the 4 packets are being received by the sender, and hence he is now waiting for the packet number 0 again, because when you are giving 4 distinct sequence number, you will give first 0, 1, 2, 3 for the first 4 frame, then for the 5th frame you will repeat it, right? 0, 1, 2, 3. So like that you will be assigning the sequence number. So that is what we see. So as 4 of them received, the receiver is now waiting for 0. Again, we cannot use 4 here as we have only 4 sequence number. Because n is equal to 4, so 0 to 3. So again, so we saw it like a minimum 4, right? So we are going to reuse it. Now suppose that the cumulative acknowledgement for the above 4, so these 4 are received, and in go back and we are using cumulative acknowledgement, and suppose that the acknowledgement timer expire a little bit later, and for these 4 packets together we are going to send the cumulative acknowledgement. That's a single one, right? So either the cumulative acknowledgement for this 4 packet is lost, or in worst case, if you are still following independent acknowledgement, suppose all the 4 acknowledgement lost, whatever it is. But normally in go back and we will use cumulative acknowledgement only, and in cumulative acknowledgement we will be sending a single acknowledgement for these 4 together, and that time if it is lost in the network, so what will happen? So that is a scenario. So let me take that example and we will come to this. So it is something like this: 0, 1, 2, 3 is being sent by the sender, and a single acknowledgement is being sent by the receiver. So this is one case. If you want, you can argue like if I am sending independent acknowledgement, then what is the scenario? The scenario should be taken like this: this one, this one, this one, this one. Everything together lost. Okay, you either take this situation, or in case of accumulated, that single one. So this is a more practical case. I mean general scenario, because in go back and we are normally using this only. And now at the receiver side, that single window at the receiver side, it is expecting as, I mean, the receiver window is 1 in the sense 0, 1, 2, 3, all of them are processed. So the receiver will be next expecting, means if it want that in order delivery, in order the fifth frame will be getting a sequence number 0, that will be known to the receiver, right, because it is something globally fixed. So it will be waiting for the frame with the sequence number 0. Okay, now what will happen, you are actually retransmitting, because acknowledgement is not there, so the timer for this 0 expires at this point. So this is a timeout timer, right? So the timeout happen at this point, and when timeout occurs, what you will do, as it is go back, and actually the situation is like everything reached the receiver, the acknowledgement lost. So that is a situation. But from the sender point of view, sender don't know whether it is data lost or acknowledgement lost. So what the sender has to assume, sender will be assuming that the data lost, right? Because the worst case it has to assume. So if this particular 0th frame lost, definitely the receiver is going to discard all the subsequent frames, right? So when it is going to discard all the subsequent frames, what will happen? The sender is supposed to transmit all others. So actually the situation is different. Everything received and everything processed at the receiver side, but the sender don't know whether it is the acknowledgement lost or the data lost. So it has to take the worst case assumption, right? It will assume like data lost. So what it will do, it will retransmit everything for a worst case scenario. So it will go back 4 position from the last sent one. So this one, starting from 0, all these things will be retransmitted. 0, 1, 2, 3, everything is retransmitted. Now see, the receiver is actually waiting for 0. As per receiver, what is the 0? The sequence number of the 5th packet. But now it is getting a packet with the sequence number 0. It will simply think that it is a 5th packet. But actually what is it? It is a duplicate frame. It is a retransited packet. But now the receiver is not able to understand this fact that this is the duplicate, because duplicates were filtered with the help of sequence number. And means in the sense 0, 0, don't think in that way. 0, as per the receiver, this 0 means the sequence number of the 5th packet, right? It is expecting 5th packet. 5th packet is next coming. Definitely we know the 5th packet sequence number will be 0, because the 0 is something already consumed, and definitely I can give 0. So that kind of an assumption we taken, and suppose that is how the protocol is working. So the receiver is waiting for the 5th packet, but the sender is actually sending the 0th packet only, the original 0th. Sorry, I started numbering from 1. Okay, sender is sending the first packet only. First packet is given sequence number 0, so that the 5th packet will be getting sequence number 0. Receiver is waiting the sequence number 0 packet, and as per the receiver it is a 5th packet. But it is actually the first packet being sent by the sender because of this kind of a situation. So when situation is normal, there is no issue at all. When you are getting a situation like this, things are going complicated. Okay, hope it is clear for you. Now tell me, what is the solution at this point? So the problem here is, the receiver is getting a packet with the sequence number 0, and it is waiting for 0. It will happily take. The duplicate packets are accepted as the receiver don't know whether it is the next set of protocol or it is the previously accepted. So that kind of a confusion is there for the receiver. So how we can resolve it? We can resolve it easily by just increasing the sequence number by 1. Just one more sequence number is enough. That will solve the problem completely. See, how to solve it. Now we are going to try with one extra sequence number. Means already we have 4. Now 4 plus 1, we are going to try with a 5 different sequence number. Same scenario, 0, 1, 2, 3, right? 0, 1, 2, 3. And suppose the packets were like, this is my frame number 1, frame number 2, frame number 3, frame number 4, frame number 5, frame number 6, frame number 7. This is for me, I am giving this number. I want to identify first frame and sixth frame for that purpose. But when it comes to sequence number, for frame number 1 will get sequence number 0, 2 will get sequence number 1, like that. 4 will get sequence number 3, and 5 will get sequence number 4. Why 4? Because now I have 5 different sequence number, that is 0, 1, 2, 3, 4. Now the 6th frame will be getting sequence number 0 and the 7th frame will be getting sequence number 1. So that is how I am going to assign the sequence number. See, listen, 0, 1, 2, 3, 4 for the first 5 sequence number, and for the 6th one I can repeat, no problem, 0, 1, 2, 3, 4. So like that I will be assigning the sequence number for the subsequent frames. Now this situation, and the window is still for, so still we are talking about go back 4 only. With the go back 4, sequence numbers we taken to be 5, right? So window, sender window will be 4 only. So the 4 packets being sent by the sender. And just like the situation we already seen, the acknowledgement, the cumulative acknowledgement for the 4 1 together is lost on the way. So the timer expire at the sender side. The sender will be retransmitting all the frames. Now we changed our sequence number concept, right? So that is something globally known to the sender and the receiver. Now from the sender point of view, 0 is received, processed, 1 received, processed, 2 and 3 received and processed, and everything is fine. Now what is needed next? I need the fifth packet, right? So for fifth packet the sequence number will be 4, because 6th packet onwards I am going to reuse the sequence number. So receiver side, the receiver knows that the next for the correct frame the sequence number has to be 4. But you know, if there is no issue like this, definitely next I will be sending 4 and it will be taking 4 and it will work fine. But as the acknowledgement is lost, the timer expires, I will be retransmitting the whole set by going back 4 position, go back n. All these things will be retransmitted, right? Now you see what is the one coming with the sequence number 0. What is expected by the receiver? Sequence number 4. Mismatch. The receiver will understand that this is because of the duplicates. So this is how the duplicates were handled in go back n, and definitely it is going to discard all of them because it is already received, right? Only the problem is with the acknowledgement, but the situation is something common for both, right? So that discards now as the receiver is expecting packet number 4, the one with the sequence number 4 is expected. It also send acknowledgement number 4 repeatedly, like I want 4, I want 4, I want 4, I want 4. It's saying like that, so that any one of them will reach ultimately, because now it is better to send independent acknowledgement, because cumulative one is actually made all those issue, right? So when I'm sending independent, definitely one of them will reach the receiver, and that time receiver can send 4 and 1. So now the receiver is saying that 0 1 2 3 I got correctly, now I want 4, you please send me 4, like that it is forcing the sender. So hope it is clear and is interesting for you. So it's a very nice concept. Try to understand it in the right sense. Again, as I already told you, I am going a little bit deeper. So because I want you to solve the problems that you can encounter in any exam. But if you don't want this much detail, just understand the concept and proceed with that. Okay. Yeah. So now this is clear. Let us just read the something. Let me clear these things. Yeah, so what means at some point from here we moved to those examples. So on the center side, packet 0, hence all the 4 packets will be transmitted again. Now it is clear for you, right? Problem now is receiver is waiting for new set of packets which should be started from 0. Now it will receive the duplicate copies of the previously accepted packets. But still it may means it can't identify it has duplicate. So we can avoid this problem by one extra sequence number. So what we'll do now, the receiver could easily reject all the duplicates. That rejection of the duplicates will be easy now, which are starting from 0, because it is expecting 4, right? That's all. Okay, hope it is clear for you. Thank you. Now we can move on to the selective repeat protocol.